Welcome to Brain Vision.
Now we have two different pressure gauges, and we know that pressure gauge is the difference between the pressure inside and the pressure outside. So we can express these two pressures as such. So we know, I'm going to say pressure 1 is the pressure inside initially, and minus P naught, which is pressure outside, is equal to 40 atmospheres. Likewise, P2 minus P naught is equal to 25 atmospheres. Now we can also assume that the pressure outside is equal to 1 atmosphere, because that's just going to be an atmospheric pressure. So we can then rewrite P1 is going to be equal to 41 atmospheres, and then P2 must then be equal to 26 atmospheres. Okay, so we want to find the mass of oxygen gas in our second reading. We can start with the ideal gas law, PV equals nRT. Now we can also express mass through molar mass, right? So we have the equation N, number of moles is equal to the mass over molar mass. So we can plug that in for our ideal gas law. PV is equal to mass over molar mass, RT. Now because volume, molar mass, R and T are constants through this process, when we have two different pressures and masses, we can express them as, through this equation, I should say, P1 over M1 is equal to P2 over M2. Likewise, you want to solve for M2. M2 is equal to P2 over P1 times M1. So we can put in our numbers for M2, which is just, well, P2 is 26 atmospheres over 41 times the mass originally is 12 kilograms, and that should be equal to 7.61 kilograms. Now this question also asks for mass withdrawn of oxygen gas, so mass withdrawn delta M is going to be equal to M1 minus M2. So M1 we had 12 kilograms, and we're going to subtract M2, which just found as 7.61 kilograms, and therefore our mass withdrawn delta M is just equal to 4.39 kilograms.